Sri Sairam. Last class we'll discuss about introduction on Born hypercycle, and now we'll discuss about covalent bond and dipole moment. What is meant by covalent bond? Kosil-Lewis also assumed that atoms attain noble gas electronic configuration. In the process of bond formation, Lewis proposed that this is achieved by sharing of a pair of electrons. Sharing of a pair of electrons between the two atoms is known as covalent bond. Example, two hydrogen atoms. Here one hydrogen plus another hydrogen, with share pair of electrons we get bond. Next example, chlorine molecule will take. Chlorine will take. Atomic valence shell is 6, 7, see here bond will take place here, two electrons are bond will take place. Next we take another oxygen also, O2. This double bond will form. It is how many electrons? It is 4 electrons will present. Next, Lewis structure. Lewis provided a very convenient way of representing bonding in a simple molecule. This is called Lewis electron dot structure, or simply Lewis structures. The Lewis structure, each element is represented by a Lewis symbol. Symbol example here, first group hydrogen and lithium, second beryllium, and third group boron, and fourth group is carbon, and fifth group is nitrogen, and sixth is oxygen, and 7 is fluorine. But here dot is there, no, that is symbol of Lewis symbol. Here lithium, hydrogen is 1 valence shell, and lithium is 1, and beryllium is 2, and boron is 3. Valence shell of boron is 3, and carbon is 4, nitrogen is 5, oxygen is 6, and fluorine is 7. These are the symbols for the Lewis. In terms of Lewis symbol, the ionic bond formation in NaCl can be represented. Here Na means here 1 valence electron plus chlorine is total 7 electrons. It is shared pair of electron. It is sharing 1 electron to the chlorine atom. We get Na plus Cl minus. The covalent bond formation in HF is represented as hydrofluoric, means HF is hydrofluoric. It is represented as here 1 hydrogen atom valence shell, and fluorine is total 7. We get here total, it is octet, we call it as, this is duplet. It is hydrogen, we call it as duplet, and fluorine it is octet structure. Next, coordinate covalent bond. In some case, both the electrons of the shared pair are contribute by only one species, atom, molecule, or ion. A common example is a formation of bond between boron trifluoride BF3 and ammonia NH3. The BF3 is an electron deficient molecule and can accept a pair of the electrons. See structure of ammonia and BF3, boron trifluoride and ammonia. See, this is bond pair of electrons, this is lone pair of electrons. It is donor, it is bond pair of electrons, this is lone pair of electrons. We call it as nitrogen is donor, this is acceptor. Acceptor, we known as coordinate covalent bond. This arrow we show that we known as coordinate covalent bond. Next, one more example. We take ammonia. Valency is 5. And next, bond with hydrogen. 1 electron to the hydrogen. Next, this is lone pair of electrons. This is bond pair plus H plus we get this is ammonium ion. This is a nitrogen is donor and hydrogen is acceptor molecule. Next, characteristics, properties of covalent compounds. First point, the covalent compounds have low melting and boiling point due to weak force of interaction between the molecules. The covalent compounds are poor conductors of electricity as this lack of ionic species. The covalent compounds are generally insoluble in water. And dissolves in the non-polar solvents like benzene, carbon, tetrachloride. Benzene structure formula is C6H6 and carbon tetrachloride is CCl4. Next, bond polarity and dipole moment. A covalent bond is formed by sharing of a pair of electrons by the two atoms each, one of which contribute one electron. If the two atoms have the same electronegativity, then sharing of the two bonded atoms is equal. Example, H2, Cl2, O2, N2. All these are example for the two atoms have the same electronegativity. Example here, chlorine to chlorine. Charges is same. A negative charge, here also negative charge. Oxygen also same, negative charge, and nitrogen also negative, but hydrogen is positive charge. But two atoms have the same electronegativity, then sharing of two bonded atoms is equal. Such bond is pure covalent bond. It is non-polar in nature. Example, H2, Cl2, O2, N2. These are the example for non-polar in nature. However, the electronegativities of the two bonded atoms are different in HCl. Then the shared pair of electrons lies more towards the more electronegative atom, that is chlorine. More electronegative means chlorine atom. As a result, a small negative charge is delta minus develops on chlorine atom, and equal positive charge delta plus develops on a hydrogen atom. The covalent bond in HCl is a polar covalent bond. Here HCl means H is positive. This positive charge means it is delta plus, and chlorine is delta minus. We call it as polar covalent bond. Next, dipole moment. Dipole moment symbol is mu is equal to magnitude of the charge q into distance of separation r. It is commonly measured in the unit dB. Symbol d. The SI unit of dipole moment is coulomb meter, cm. The two units are related as 1d is equal to 3.336 into 10 to the power of 30 coulomb meter. Some few example for dipole moment. Bond, electron negativity of halogen atom, dipole moment. HF, SCl, HBr, and HI. The electronegativity of halogen is 4, 3, 2.8, 2.5, and dipole moment is 1.9, 1.04, 0.79 and 0.38. All these are example for dipole moment. Dipole moment is a vector quantity since it has a direction and magnitude both. By convention, the symbol is used to represent the dipole moment with tail on the positive center and head on the pointing towards the negative center. This is a tail on the positive center. This is positive, no, hydrogen is, and chlorine is negative. The head of pointing towards the negative center is chlorine and hydrogen is positive center. The dipole moment of HCl is represented as this same. Next example for dipole moment. First one is carbon dioxide, CO2. CO2 molecule is a linear triatomic molecule. Each C double bond O bond is polar with the oxygen atom, having the negative end of the bond dipole. It is end of the dipole moment. It is oxygen is negative end of the dipole moment. The dipole moment of the both the C double bond O bonds have the same magnitude but are in a opposite direction. It is opposite direction since they are cancelled to each other. The net dipole moment of CO2 is 0. Very, very important, the net dipole moment of CO2 is 0. Next example, ammonia, NH3. Ammonia has a pyramidal structure which makes the arrangement of 3 NH bonds. 3 NH bond unsymmetrical. 3 NH bonds are unsymmetrical and each NH bond, nitrogen is a negative center. This is nitrogen is negative center and nitrogen is a negative center and hydrogen is positive center. This is positive, nitrogen is negative and hydrogen is positive. The net dipole moment of ammonia is 1.47 dB or 4.90 into 10 to the power of minus 30 coulomb meter. This is known as ammonia structure. Next, Fusion's rules. Fusion proposed some empirical rules that deals with the polarization process. The factors increase the covalent character of the ionic bond. First one, small cation and large anion and I positive charge on a cation. Next, covalent bond parameters. There are main 4 types is a bond order, bond length and bond angle and bond enthalpy. We'll discuss one by one. Okay, first we'll discuss about bond order. The bond order is a number of bonds present between 2 atoms in a molecule or ion. Generally, bond order has a integral value. Example, bond order is 1. The bond order is 1 when there is only one covalent bond, that is sigma bond. One covalent bond is sigma bond between the 2 bonded atoms H2Cl2 NH3. Write the structure of H2Cl and ammonia NH3. See here how many bonds are there? Only one bond. Here also one bond. It is known as sigma bond. Here also, here NH is total 3 bonds are present, that we known as sigma bond. These are called single bond. Next we take another bond order 2. Example, O2 CO2 C2H4. Here how many sigma bonds are, how many pi bonds are there? Here 2 covalent bonds present and 1 sigma bond, 1 pi bond, 1 sigma bond and 1 pi bond. And here also same, CO2. Here C double bond O is 2 and here C double bond C is 1. 1 pi bond and 1 sigma bond will present in bond order is 2. That these are called in a double bonds. Here all present in double bond only. In this structure all present in double bonds. Next we take one more third example. Bond order is 3. Example C2H2. The bond order is 3 when there is only 3 covalent bond. 1 is sigma bond and 2 is pi bond. This is known as bond order is 3. This is example for C2H2 is bond order 3. These are called triple bond. We call it as triple bond. Next we will discuss about bond length. The bond length is the distance between the nuclei of the two bonded atoms. It is expressed in picometer pm. The bond length depends upon the size of the bonded atoms and the bond order of the bond linking them. The greater the bond order, the smaller in the bond length. Greater in bond order and smaller in the bond length, that is known as bond length. See some example for bond length. Here this first column bond, next column is bond length. First column will some examples are there: HH, HF, HCl, HBr, HI. The bond length is HH means 74 and HF is 92 and HCl is 127 and HBr is 141 and HI is 160. All these example for bond length. Next, bond angle. It is the angle between the two bonds in a molecule. Since covalent bonds are formed through overlapping of orbitals, it may also depend as angle between the two orbitals that contains bonding electron and overlap with atomic orbitals other atoms. Here this arrow is showing that we measure in bond angle. Example, water molecule, methane, all this discuss about next slide. See, bond angle between two OH bond in H2O molecule is 104.5 degree. That is water molecule bond angle. And NH, between NH bond in NH3 molecule, the value is 107.3 degree. And between CH bond is methane, value is 109 degree and 28. These are the bond angles measured in water and ammonia and methane. Next, bond enthalpy. It is the amount of energy required for breaking 1 mole of bonds of a particular type in gaseous molecules. It is also called bond dissociation enthalpy, and it is applicable to simple molecule containing only 1 bond of a particular type. Example, the bond enthalpy of Cl minus Cl bond in Cl2 is 243 kilojoule per mole, and see O double bond O in O2 molecule is 498 kilojoule per mole, and nitrogen N2 is 946 kilojoule per mole. Next, some few examples for bond enthalpies. Bond enthalpy and kilojoule per mole. Hydrogen and HC, HN, HO, N, OO and FF. These are bond enthalpy values is 436, 414, 391 and 464, 159, 138, 157. Next, here some few bond and this is there N triple bond N and O double bond O, C single bond C and C double bond C, C triple bond C, C triple bond N and C single bond Cl. Bond enthalpy or kilojoule per mole 946, 498 and 347 and 611 and 837 and 891 and 330. This all in bond and bond enthalpies. Today's assignment questions. Each question one mark. What is chemical bond? Second question, define electrovalent bond or ionic bond. Third question, what is a coordinate covalent bond? Write the SI unit. Fourth question, write the SI unit of dipole moment. Thank you, Sarah.